Now we're going to take a look at question 21 out of 9.2. Refer to dataset 24 word counts and use the measured word counts from men in the third column and the measured word counts from women in the fourth column. Use a 0.05 significance level to test the claim that men talk less than women. So our claim here is that on average, men talk less than women. The opposite of that is going to be that the mean of men is greater than or equal to the mean of women. That allows us to build our hypothesis statement. So we went with mean of men first. We went with mean of women second, so we have to be consistent with that the rest of the way in the problem. What goes between them in the null? Equal, because it's always equal in the null. And then we have a strict inequality less than in the claim. So we put the R in the S, and since it's the alternate that represents the claim, we're going to note the S here for when we write the conclusion with respect to the claim. So this is a left tail test because the inequality in the alternate is pointing to the left. Our significance level, alpha, is 0.05. And we're working with raw data here, so there are no given statistics. The reason we normally identify the given statistics is that's what we're going to enter into StatDisk. Unless we actually have raw data to work with, we do, so we don't have to worry about that. We can also write our rule of rejection, and our rule of rejection is reject null hypothesis if p-value less than or equal to whatever alpha is, and that's 0.05. Our test statistic is going to be t, our p-value is going to be our p-value, but let's line it up so it's right below that in the rule of rejection. And now we're ready to head on over to StatDisk, open up dataset 24 and use columns 3 and 4. Men are in the third column, so that has to be our first sample here. So everything else is going to be consistent. So dataset, 13th edition, 24. Analysis, hypothesis testing. Now here we're working with raw data. So in raw data, maybe it's match pairs, maybe it's independent samples. Well, let's take a look. Well, first off, what we see here is if we scroll down, column 3 and column 4 have different sample sizes. So this can't be matched pairs. Also, in what they told us in the setup of the problem is they gave no indication that man number 1 in column 3 has anything at all to do with woman number 1 in column 4. So there's no reason to believe that these are matched pairs, so independent samples. Alpha's 0.05, this was a left tail, and we're using data. So column 3 for men, that's our sample 1. Column 4 for females, that's column 2. Again, we weren't given anything at all to make us change the default for method of analysis. We can hit evaluate and plot. And what we see here in our graph is that our test statistic does not fall in that lower tail. In fact, our test statistic is really close to 0. So our sample result is a little bit more than 0.1 of a standard deviation below what we'd expect if these two means were equal. So we got a result really consistent with these two population means being equal to each other. So let's go ahead, take this back to here. And so our test statistic, negative 0.132. our p-value 0.4477. So our p-value is not less than our significance level, so we will not be rejecting the null hypothesis. We fail to reject the null hypothesis. And when we fail to reject the null hypothesis, that is when we have insufficient evidence. We don't have the evidence to, we noted the S is for support. So we don't have the evidence to support the claim that men talk less than women. So we have insufficient evidence to support the claim that men talk less than women. We failed to reject the null hypothesis. We failed to throw away the idea that the mean from men is equal to the mean of women. We couldn't say that that wasn't the case. So does that mean that men and women on average talk the same? Not necessarily, but the results were consistent enough with that idea that we can't say that it's not the case. And again, we generally assume, and that's what we see in the null hypothesis, the no change, no difference, no relationship, no effect. What we got here specifically is in the null hypothesis is the no difference case. And that's what we went with our underlying assumption, and we don't have the evidence to say that our underlying assumption is incorrect.